Okay, welcome to section 4.1 on probability distribution. So today we're going to distinguish between discrete and random variables and a continuous random variable. We're going to construct a discrete probability distribution in its graph, determine if the distribution is a probability distribution, find the mean, variance, standard deviation, discrete probability distribution, and find the expected value of a discrete probability distribution. Throughout this video, I encourage you to stop and pause so that you can write down everything that is necessary because I will be going through the material quite quickly. Okay, first off, we have a random variable which represents a numerical value. We usually call it x, and it's associated with some sort of outcome of a probability distribution. For example, the number of sales calls a person might make in one day, or the number of hours spent on calls in a particular day. So that would be what a random variable is. So you have what is specifically a discrete random variable, and it has a finite or countable number of possible outcomes that can be listed. For example, the number of calls a salesperson can make could either be 1, 0, 1, 2, 3. It's a discrete or countable list. Versus a continuous random variable, it has an uncountable number. So like the number of hours spent on a sales call in one day, you don't have to spend 1 minute or 1 hour or 2 hours. You could spend 1.5 or 1.25. You have this whole spectrum that you could list. So it's this continuous list and not just a discrete number. So we have an example. So for this one, we're going to decide whether the random variable is discrete or continuous. So the number of Fortune 500 companies that lost the money in the previous year. Well, that is a countable thing. You could have 0 that lost, or 1, or 2, or 3, or up to your 500 for the Fortune 500. So that would be discrete because we're counting the numbers. However, here we have the volume of gasoline in a 21-gallon tank. You don't just have to have the whole number of gallons. You can have any number between 0 and 21 for the number of gallons in your tank. You can have fractions and decimals, so that usually indicates that it would be a continuous random variable. So for discrete probability distribution, we're going to list each possible value the random variable can assume together with its probability, and it needs to satisfy these conditions. The probability of each value is going to be between 0 and 1, including 0 and 1, and the sum of all the probabilities equals 1s. So we have them in words and we have notations. So probabilities being between 0 and 1, that was just something that we had before. Here we're having that the sum of all probabilities equals 1. So x is the discrete random variable, and we have these n different outcomes. So when we're making a probability distribution, we're going to make a frequency distribution for the possible outcomes. That's what we've done before, frequency distributions. We're going to find the sum of the frequency distributions. We're going to find the probability of each of those outcomes by dividing it by the frequency, by the sum of the frequencies. And we're going to check that each probability is between 0 and 1, and that the sum of all probabilities equals 1. So here's an example. So an industrial psychologist administered a personality inventory test for passive-aggressive traits of 150 employees. Individuals were given a score from 1 to 5, where 1 was extremely passive and 5 was extremely aggressive. A score of 3 indicated neither trait. Construct a probability distribution for the random variable x. Then graph the distribution using a histogram. So step 1 is to make a frequency distribution. So we have our frequency distribution already created for us. So if you had a score of 1, that happened 24 times. A score of 2 happened 33 times, and so on. The sum of the frequencies is step 2. If we add up all of those, we get 150 because that represented the 150 employees. Step 3 was to divide each of the frequency by the total number. So for 1, so the probability of getting a score of 1 was 24 out of 150, and so on. You can see all the probabilities. And then we just list all of the probabilities into a table. So when your random variable x was 1, your probability was 0.16. And when the x was 2, the probability was 0.22, and so forth. So this table here is the discrete probability distribution. So then once we have our probability distribution, we want to make sure that is valid. We want to check that each of these probabilities is between 0 and 1, which it is, and then you want to find the sum of all of those probabilities. We add them all up and it equals 1. So this is a valid probability distribution. So that would be the last step. So the problem that also asks you to to create a histogram. So you can see at 1, the probability is 0.16. Oops, I'm sorry. So at 1, it goes up to 0.16, and at 2, it goes up to 0.22. Remember, the bars all need to be equal width, and the bars need to touch. So for this one, because the width of each bar is 1, the area of each bar is equal to the probability of that particular outcome. Okay, so let's move on. So here we're going to find the mean of a probability distribution, and the mean is the sum of all the x times the probability of x. So we had our table, we had the first row with the x's, and the second row is the probabilities, and we're just going to multiply all of the x's and the p of x's, and we're going to find the sum. So for this particular example, for the personality inventory test, we had the 1 and the 0.16. These were the same ones. So we're going to multiply those to get our x times p of x. And 2 times 0.22, multiply those, and you get your x times p of x. So we find our x times p of x. So we're multiplying our two columns, and then you add up all of those, and that's the sum of x times p of x, which is our mean, which in this example is 2.94. So we can also find the variance and the standard deviation. So the variance, we write sigma squared, and it's the sum of, so we do x minus the mean for each of our x's, and then we square it, and then we're going to multiply it by the probability for that particular x. And the standard deviation, just like it was before, it's the square root of the variance. So here we have the same example. So we had the 1 and the 0.16 for the x and the p of x, and we computed the mean for that in the previous example. So now we're going to find the variance and the standard deviation. So first step is we have our x column, we have our p of x column, and then we have to do x minus the mean. So we're going to find x minus the mean for each of those. So you can just subtract your x from the mean to get negative 1.94, and then you have your x is 2 and the mean is 2.94, so you do x minus the mean and subtract those numbers, and all the way down. The next step would be to square those numbers. We have negative 1.94 and we're going to square it, and then we have negative 0.94 and we're going to square it. So we square all of our x minus the means in this column here, and then the next step would be to take your x minus your mean squared and multiply it by your probability, your p of x. So we have this 3.76, which is your x minus mean squared, and we'll multiply it by the probability, which is 0.16. So you have 3.764 times 0.16. The next one, you take your x minus your mean squared, and we're going to multiply by your, multiply it by your probability of your x. So we multiply all of those together. So we're multiplying the x minus the mean times the probability of the x to get this one. And then the variance says to sum up all of those, which is 1.616. The standard deviation is going to be the square root of the variance. So the standard deviation sigma is the square root of the variance. We're going to square root 1.616 to get 1.3. So the next example is expected value. So the expected value of discrete random variable equals the mean of the random variable. So E of x is the expected value of x. It's the mean, and it's the sum of the x times the p of x. So in this example, we're going to find the expected value. At a raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. You buy 1 ticket. What is the expected value of your gain? So you're going to spend $2 for 1 ticket, and you have these possible outcomes that could happen. And there's 1,500 tickets sold total. So what do you expect to gain or lose from your 1 ticket? And that's what the expected value is. So the solution is we're going to find the gain for each prize, and we're going to subtract the price of the ticket from the prize. So a $500 prize, you spent $200, so the possible gain would be $498 if you bought 1 ticket and you won the $500 prize. So if you won the $250 prize, your gain would be $248 because you won $250, but you spent $2 to buy that ticket. For a $150 prize, your gain would be $148, and if you won the $75 prize, your gain would be $73. If you don't win the prize, which is most likely what's going to happen, your gain is going to be minus $2 because your gain is nothing if you win, but you spent those $2 on the ticket, so your gain would be a negative 2. So a negative number represents a loss, whereas a positive number represents a gain or a win. So we're going to do a probability distribution for all the possible gains, all the possible outcomes. So our outcome could be a gain of 498, $248, $148, or $73. So these represents the 4 different prizes we could have, or the most likely outcome is going to be the negative $2, which is the example of your loss. The probability for each of those is 1 over 1,500 because there's going to be one winner of the $500 prize, and there was 1,500 tickets sold. There was one $250 winner out of the 1,500 tickets sold, and one $150 winner and one $75 winner. So those were 4 of the 1,500 tickets. So the 1,496 tickets were all tickets of people who lost. So the probability of losing $2 is 1,496 out of 1,500 because there was this many tickets that are not going to win a prize out of this many tickets that were sold. So to find the expected value, it's the sum of the x times the p of x. We have our x and our p of x in our probability distribution table. So I'm going to multiply x times 1 over 1,500, and I'm going to add it to 248 times 1 over 1,500. And we're going to add it to the next x times p of x plus the next x times p of x plus the next x times p of x. So we're going to multiply our x times our p of x for all of these and add them all up. And remember that this last one was a negative here, so it's a negative 1.35. So what that means is, on average, you would expect to lose $1.35 for each ticket you buy. Now, what's going to happen is either you are going to win or you're going to lose, but on average, it's an expected loss. See how it's negative? It's a loss of $1.35. And that's expected value. Okay, so in this lesson, we distinguished between a discrete and a continuous random variable. We constructed a discrete probability distribution. That was the table with the x and the p of x, and then we did its graph, which was the histogram. We determined if a distribution was a probability distribution. Remember that the numbers for all the probabilities had to be between 0 and 1, and that all the probabilities had to sum to a 1. We found the mean, we found the variance, and we found the standard deviation. So we had the formulas for that. And then we found the expected value of a discrete probability distribution. And that's all we have for 4.1.